there are some bugs. For example, there's one that I would say affects most code bases out there, which is the standard, you have an HTTP endpoint and the body is JSON, so you want to decode it. So what you do is you take the r.body and you do json.newDecoder.decode with the body and then into some structure. And if you do that, it's buggy if you just do that.
I've just got to go. What do you mean it's buggy? Tell me why, please.
Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. Linode makes cloud computing simple, affordable, and accessible. Whether you're working on a personal project or managing your enterprise's infrastructure, Linode has the pricing, support, and scale you need to take your ideas to the next level. We trust Linode because they keep it fast and they keep it simple. Check them out at linode.com/changelog.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. This episode is like a 2 for the price of 1. You get a fascinating conversation about Go's encoding JSON package, plus a murder mystery, as a sneaky little bug was determined to kill Daniel's laptop. Don't miss the post show because Daniel put on his sleuthing hat and cracked the case just in the nick of time. Okay, here we go.
Hello and welcome to Go Time. I'm Matt Ryer. Today we're talking about JSON. You'd be forgiven for thinking this is going to be the most boring episode, but I guarantee you it will not be. Joining me today, Johnny Borsico. Hello, Johnny.
Hello, Matt.
Have you had a good week so far?
Yes, but we're about to talk about JSON, so I don't know. We'll see.
Let's see. Well, don't worry, though. We do have a great guest today, a very prolific contributor to Go. You've probably seen his name around, Daniel Marti. Hello, Daniel.
Hi, happy to be here.
Welcome to the show. Great to have you. Have you had a good week so far?
Yeah, we almost got to 20 degrees in the UK, so that was nice. But summer was over a few weeks ago. It only lasted for a weekend.
Yes, we do have some more heat coming later this week, so stay tuned for that. I don't know why I sound like a news anchor. I'm just trying to be a normal human, but I find that difficult sometimes. Okay, so let's start then. Just quickly for beginners, in case there's somebody that's really brand new. What is JSON? Do you say it like that? Do you say JSON or do you pronounce it some other way?
So I just say JSON, and I think if I had to explain this to a little kid, I would say it's kind of like a way to represent data. And that's already gone out the window, the plan to explain this to a little kid.
No, kids get that. Yeah, let's assume it's a really smart kid.
Mm-hmm.
Mm-hmm. Yeah.
So it's like a very generic way to represent data. So it doesn't matter who the other reader is, who's on the other side. They most likely will be able to read that data.
Yeah, and it's JavaScript Object Notation. So it comes out of JavaScript. But it turns out to be really kind of useful across every language really has now some kind of JSON support.
It's practically everywhere. Practically every language out there that's modern today has to have JSON support because you just do. And your computer, you might not see it, but it definitely is running JSON at some level.
Yeah, and so there's it's an object and it has fields, and those fields have some types. And it's the types that we're used to as well in Go, like strings and numbers and Booleans. Any others? Other objects, arrays, those kinds of things. I think that might be the whole list. And why did it get such popular use on the web? I mean, it is kind of perfect, isn't it, for web technologies?
I would say it came from all the success that browsers had, the modern web had. And, suddenly HTTP, HTML, CSS, and JavaScript, and JSON, all these technologies kind of took everybody by surprise. Initially, everybody thought they were just toys. But now suddenly people are building real companies on top of them. And JSON is just, has too much momentum. I don't think anything is ever going to replace it at this point, honestly.
That's really interesting.
Well, hang on. I'd like to add something here. I like what you said, Daniel. There's another reason, I think, my personal reasons as well, why I think JSON sort of took off. Because primarily for me, it was because it was not XML, which is prior to that,
Yes.
prior to JSON taking over. If you wanted sort of an interchangeable format with other systems and things like that, sort of JSON, or rather XML, was the sort of the default go-to, right? And then we created a whole like ecosystem around XML, like parsing XSLT and templates, style sheets, and all kinds of really, looking back, kind of brilliant technology for the times, but just really, really hard to sort of work with. You really had to depend on sort of a machine generated XML, because sitting down and sort of editing XML by hand, especially like huge, large like documents, like dealing with that, I mean, that was like maddening. So here comes JSON, making it very simple, very human readable, right? And it was like a breath of fresh air. So absolutely, to corroborate sort of the idea that it sort of became very, very popular with the rise of HTML, JavaScript, CSS, like building applications, right, on the web. From a systems and data interchange standpoint, it was revolutionary just as much.
Yeah, and it's simpler also than XML too, because in XML you can do weird things with the structure, like you can just have siblings next to each other. That gets very complicated to work with. You can't do that with JSON, can you? There is a tighter structure to it, and I think that kind of helps as well. What about any gotchas with working with JSON? Is there anything that beginners ought to watch out for? One thing that occurred to me is in Go, if you have a time type, so you're going to represent a time as JSON, it turns that into a string, doesn't it?
Yeah, I am actually not sure exactly what happens, because I usually just write custom code to handle times in JSON.
Really?
Because
Why?
Most of the time people will want times, or rather timestamps, in a very specific format. So they will write the code to handle that. So I actually don't remember what the default behavior is. But yes, JSON doesn't have a timestamp type, so it will just end up as a string.
Yeah. Which is fine as long as the thing that's interpreting it also understands that format and can then work with it. But that's quite an interesting point, is that there are some rudimentary types in JSON, and sometimes you have to do a bit of magic to turn your particular data into something that's going to work in that text-based kind of format. And another thing that's quite weird is that by default, I think the numbers are all float 64 type. If you're working with generic data, you can use the map string interface type in Go to unmarshal JSON into, and it will work. It'll fill that map up as like it's the object. But of course, if there's the numbers in there, it's not sure whether it's a floating point number or an integer or whatever. And so it just uses the most kind of useful type, or the most versatile type, the float 64. I found that to be quite strange when I first started working with JSON in Go.
And I actually think numbers are a really interesting point, because I think JSON could have gone one of two ways. One of them would have been, you've got integers on one side and you've got floats on the other, and then you define what the sizes and bits of those are. So for example, if this was Go, we could have said int 64 and float 64. And that has some advantages. It's stricter. So if you want to use one or the other, it's guaranteed that it's going to stay that way, and you're not going to lose any precision or anything like that. But on the other hand, if you just say it's going to be a number, then that opens the door to, for example, supporting arbitrary precision numbers, aka big numbers, which Go also supports with a different package.
So the encoding JSON package, which, by the way, Daniel, you actually co-maintain the encoding JSON package in the standard library, right?
Yeah, that's right. And I should mention, before we go on, I've noticed something weird on my laptop, which is that my memory usage has been rising steadily for the past 15 minutes.
Oh.
I don't know if that's a bug in Zoom or in my recording program, but I think my laptop is going to crash in about 10 minutes. So if that happens, just FYI.
Well, it's exciting though. It's like there's a bomb that's going to go off, and we're just sort of waiting.
It started at 30%. I'm currently at 92%. So yeah, about 5 minutes left, maybe. I don't know what's going on.
Okay, well, if you just disappear, we'll assume it's that. I just hope it doesn't happen after like Johnny says something and then you just cut off, because he's definitely going to take that personally.
Apologies. You asked about co-maintaining and encoding JSON, and yes, that is correct. I've been helping for, I guess, about 3 or 4 years now.
Hmm.
And JSON does have active maintainers. I believe they are Ross, Joe, and Brad. So I started helping mainly with just little bugs and little optimizations. But over time, these are all busy people. So it's gotten to a point that I do almost as much work as they do. And on one hand, it's very rewarding work because it's a very useful package used by tons of people. But on the other hand, it's kind of stressful.
Is it? Why?
Well, on one hand, because I'm nearly at 100%.
And his memory's run out.
There we go.
Yeah.
Quite literally, yeah.
Linux.
How much time does your team spend building and maintaining internal tooling? I'm talking about those behind the scenes apps, the ones no one else sees. The S3 uploader you built last year for the marketing team, that quick Firebase admin panel that lets you monitor key KPIs, maybe even the tool your data science team hacked together so they can provide custom ad spend analytics. Now these are tools you need, so you build them, and that makes sense. But the question is, could you have built them in less time, with less effort, and less overhead and maintenance required? And the answer to that question is yes. That's where Retool comes in. Rohan Chopra, engineering director at DoorDash, has this to say about Retool. Quote, "The tools we've been able to quickly build with Retool have allowed us to empower and scale our local operators, all while reducing the dependency on engineering," end quote. Now, the internal tooling process at DoorDash was bogged down with manual data entry, missed handoffs, and long turnaround times. And after integrating Retool, DoorDash was able to cut the engineering time required to build tools by a factor of 10x and eliminate the error-prone manual processes that plague their workflows. They were able to empower backend engineers who wouldn't otherwise be able to build front ends from scratch. And these engineers were able to build fully functional apps in Retool in hours, not days or weeks. Your next step is to try it free at retool.com/changelog. Again, retool.com/changelog.
Daniel, what are the challenges? Why is it stressful maintaining the encoding JSON package?
So I think it's very rewarding because the moment you fix any bug, suddenly there's tons of people that are happy about it. And clearly there are tons of people that care deeply about how fast the JSON package goes. But on the flip side, because it has so many users, if you mess anything up, you're in big trouble because people are going to be very angry. And there's also something called the Go 1 compatibility guarantee. And that essentially says if your program works with Go 1.0, it should also work with Go 1.2 and Go 1.3 and so on.
Interesting. Does that include mistakes if there was like a bug or something in that original JSON version? Does that still have to be supported?
That is a very good question. So I think there's multiple ways to interpret that because I think the most aggressive way to interpret it would be, only the things that are documented to work will remain to work that way. So if you write some code that just happens to depend on some implementation detail, that is allowed to break at some point in the future. And that is generally how I read it. But the more conservative way to read it and understand it is, no, like pretty much anything you do, if it's reasonable, even if it's not documented, it should keep working because we don't want to break the users. And in between those two ends, there's some middle ground that the team has to choose.
Well, it's a fine line to walk, isn't it? But it's so important, that V1 promise, because that's really how we're able to rely on the fact that we can build systems and we know that they're going to keep working with future versions of Go. That turns out to be one of the big selling points for me of Go itself. So I really do appreciate the effort because I know that isn't an easy thing to do. I would have thought that the JSON package, after it was first written, it's kind of done. It's sort of working. So what maintenance is there to do on it?
That is also a good question. And I think it kind of goes back to how flexible JSON is. Because JSON doesn't have a schema. It's just data in some structure. You can do lots of things with it. And people do lots of weird things with it. So then they come to the encoding JSON package in the standard library. And they expect all those things to fit their workflow with this library, right? So they might want, decode some fields depending on what this field is, or they might say, I want to stream a really, really big object, even if it doesn't fit in memory. And all those sort of use cases that you might not think to use JSON with initially, but people do use JSON with. So there's a constant stream of feature requests, but there's also a constant stream of optimizations and bug fixes caused by previous changes, if that makes sense.
Yeah, I see. So just sort of, I suppose, like any other bit of software, it's, you can improve it, you can work on it, and as you do that, you create some other problems, But it's well tested, isn't it? The tests are decent in the encoding JSON package.
Yeah, for the most part, I would agree. Yeah.
Yeah, and which is important. That's sort of what allows you to act with confidence. You talk about you don't want to break the backwards compatibility promise. Unit tests are really the way to ensure that, aren't they?
Mm-hmm. Actually, checking that your package is well tested is kind of an art, I would say, because you can obviously look at the code coverage from the Go tool, but that doesn't cover everything, because you might be covering a line, but you might not be covering all the logic that's encoded within that line of code.
Right.
Or you might not be hitting one of the edge cases that might panic or something like that.
Yeah, see, I always tell people not to shoot for like 100% code coverage in their application code, just because you kind of can tightly couple really your tests to your implementation. Is this an exception to that? Does it make sense in this package to have 100% code coverage?
I would say for the most part, it does make sense to try to go as high as possible, because for the most part, the package is just if-else's with logic. But there are also some places with like panics of things that should never happen, or also things like, I'm trying to think of another edge case. Well, there are certain edge cases that you say, this really should never happen and it's going to panic. So you could write tests that catch those and recover. And I guess you could say even that you should, but I don't think they do at the moment.
Interesting. Yeah, because there's some weirdness around. It's quite unusual actually as an API, because you pass in a pointer when you want to unmarshal it. You pass in a pointer to the destination, essentially, where you want that JSON to be unmarshaled into. And there's some kind of interesting, tricky rules around what you can pass into that thing, aren't there?
Yep. So you can essentially pass a pointer to any valid data. So it can't be a pointer pointing to nil, to 0, because then it can't actually store any data there. So essentially, it just expects the pointer to a structure that it can actually decode the incoming JSON into. And there are various rules around there. For example, if you pass it an empty interface, it's going to sort of make a guess as to what it should do. So if it sees a number, it's going to assume float 64. And if it sees an object, it's going to use a map. But if you give it, for example, a struct with very specific field types, then it is going to follow your lead. And if any of the types don't match, it's just going to error.
There's some intelligence that's sort of built into the package as well, which I usually appreciate. Very recently, I was sort of doing a PR review, and we had a developer who was sort of creating a struct, right, and providing the annotation, the JSON annotation next to the fields. But the data wasn't really there was no inbound incoming sort of a data, right, to unmarshal into. So in that case, I'm like, well, unless you really anticipate that sort of the data that you're pushing out, that basically the field names are going to be different from what they are named in the struct itself, you don't really need to annotate your fields for your structs, right? So the JSON package is going to sort of follow your lead, as you say, Daniel. It's going to basically look at the name you've given your fields and actually use those names in the JSON output, right? So you don't have to add that annotation there. So there's a lot of smarts like that I can certainly appreciate that's built into the package, and this is something that we're going to get more into as well. I like the standard library. I like using the standard library because maybe it's the nature of my work, but I tend to not sort of look for third-party packages, right, to do certain things if I can find something in the standard library, even if it's a little harder to deal with or a little less performant or whatever the case may be. We're seeing sort of if you've been in that community for any length of time, you've probably come across other third-party packages, community-built third-party packages that have made their own trade-offs, right, with regards to the implementation for JSON parsing and marshalling and unmarshalling and all that stuff. And a lot of them seem to be focused around speed and performance, right? Again, Dave Cheney's own sort of experimentation, which is published, and hopefully, we wish he was here to discuss it. But there's that sort of, I'm curious to understand sort of when is a good reason to deviate from, say, the standard libraries approach, right? Everybody wants fast, right? It's fast. Oh, it's faster. I should use that, right? Well, there are trade-offs there too, right? You don't pick it just because it's faster, right? But I'm curious to sort of on your take, right, as to why pick one over the other, what sort of trade-offs you're making, and along those lines.
I think that topic is at the heart of this whole discussion, because it is true that a lot of people want the fastest JSON decoder out there, and some of them might not realize the trade-offs at play. And I have mixed opinions and feelings about all the third-party JSON reimplementations out there. I think some of them do make sense. For example, one use case is you do absolutely want the most performance you can get, because maybe this is a bottleneck for you, and you don't mind Go generating some code to then, generate automatically a decoder for you for JSON. So you can use packages like EasyJSON for that, which is pretty popular. And the trade-off there is you have to run Go generate, and your binary is going to weigh quite a little bit more because it has quite a lot of extra code. But that extra code, it just encodes all the logic directly in binary code, in machine code. So there's no reflect, there's no dereferences, there's no extra work involved. So I think that's clearly one of the cases where it might make sense for your use case.
I like how you framed that as well. You're saying maybe it's a bottleneck in your case. And that's the thing. It's like once you've seen that this is a place where an improvement is going to make a difference for you, then it's worth taking on the extra pain, whether it's complexity or learning a new API or whatever it is. I like that approach because, well, I think it's what we should always be doing. As you alluded to, Johnny, we kind of can get a bit obsessed with why wouldn't we want the fastest possible thing? And the answer is it might be good enough just using the standard library. What are some of the packages and how are they different?
So another package that I saw fairly recently, which is interesting, I forget what it's called. It was named after a company, but essentially what they did was they tried to keep the same API as the standard library. So they said there's a drop-in replacement, but under the hood, they did something which was interesting, which is instead of using the reflect package, and reflect is one of the major contributors to why encoding JSON is slow, they used unsafe directly. And the trade-off there is if you use unsafe, you can do a lot of magic and it's very fast, but it's also unsafe. So I kind of have mixed feelings about telling people that it's a drop-in replacement, because that sort of just tells them, oh, I just changed the import and suddenly it's twice as fast. But they're not realizing what a big security hole they've just opened. Because it is true that Reflect itself does use unsafe underneath, but Reflect is very well scrutinized and reviewed, and it follows the Go rules for what fields you can set and so on. And if you use unsafe directly, you just skip all of that and you're on your own.
And the standard library uses Reflect because, in a sense, there's some kind of, it's dynamic, isn't it, in a way? It's dynamic data you don't necessarily know. Especially if you're unmarshalling into a map string interface, you don't know necessarily the structure of that JSON. And that, by the way, can be an extremely powerful thing, but can also be quite easy to abuse. Yeah, that is an interesting point you make about the using unsafe in that way. I can see why they did that, but yeah, that's funny. One use case that I've used JSON for before in quite a strange, or maybe not, way was just a command line tools which they took in through standard input lines of JSON, and then their output were lines of JSON. And just that, we had a series of different tools that we could chain together in different ways, just kind of passing around, different objects, just different JSON objects, each one on its own line. And the JSON, when you create the marshaller, you create the decoder or the encoder. Those types take a reader, an IO reader, don't they? So that they can unmarshal an object, they break at the line feed, and then you can reuse it and keep unmarshalling objects in that way. So that, as a design, was perfect for this situation because these tools basically didn't do anything until a line of JSON came in through standard in. They'd then process it, and then you get the line printed out. But there's also the directly using the marshal and unmarshal functions too. What's the key difference between those?
So I think most people would say that the difference is the streaming. So if you use marshal or unmarshal, you can look at the function types and you can see that they take and give a slice of byte. So it's pretty easy to tell that, if you're marshalling a chunk of JSON, you have to have that chunk of JSON in memory. And if you look at the decoder, it takes a reader. You might then suspect that, oh, this is going to stream the JSON in, so I don't have to load it all into memory. But that's actually not the case. And I think it's one of my main gripes with the current API. I'm not going to say it's wrong, but it's misleading to a certain degree. Because what it will do is it will buffer an entire JSON value, such as an object. And then once it's buffered the whole thing, then it's going to decode it. And there's a good reason for that. And the reason is because the encoding JSON package essentially prefers correctness over everything else. And it has some semantics for when you decode into a value, it's going to merge the decoded data into that value. So for example, if you decode into a map and that map had the key foo, and then you decode a new key bar, you end up with both keys foo and bar. It doesn't just replace the previous map with a new map. And that is useful for some things. But most people, they just decode into an empty value. They don't care about what was there before. So for most people, this is surprising because they don't care about this property. And the way the encoding JSON package implements this property is tokenizing all of the input. So if there's any syntax mistake in the input, or if it's invalid JSON, then it's not going to decode anything because it's going to do a second pass. And in that second pass, it is actually going to write to the destination.
Yeah, that makes sense. I saw another JSON implementation, which essentially it didn't unmarshal, it didn't try and turn the JSON into structured data, but you could use it to just find specific key paths. So you might say, here's the JSON stream or the JSON string, and I'm looking for author dot first name. And so just by sort of reading it, skimming it really, not trying to understand and extract all the fields and figure out data types and all that, but just looking for that particular key path. And that's another approach. If in a particular case, all you care about is a single field, that's a very fast way to get that field.
I'm having XPath flashbacks.
Yeah, kind of. Yeah.
And yeah, that's actually a very good point. I forgot about that extra use case. And I think that library is called, at least the most famous one, JSON iterator or something like that, or JSON iter.
Right.
And I think it's useful for two use cases. One of them, you mentioned, it's getting just one field or one value. And if the JSON is very big, you can save a lot of work by just skipping to that a little bit. And I think the other one is, what if you don't know what the data looks like? Because JSON, at least the encoding JSON package, forces you to know upfront what all of the data is going to look like. And you can use something called JSON.raw message to sort of delay parsing chunks of the JSON, decoding chunks of the JSON. But that's kind of like just forcing you to do multiple decodes, to do it in multiple stages. If you want to quickly look at this, and then if it's X, then do that, otherwise do something else. If you want to encode that logic into your code, using something like that package might be a little bit easier for you. But I would say that for most people, they do know what their JSON is going to look like.
Yeah. In my experience, it's better if you do know what the JSON is going to look like. Don't be tempted by this idea that your app can just support any data structure, because that will come back to bite you, is my experience. What does that raw message actually do then? Is it just like a string type or a slice of bytes or something? What is it?
It is exactly a named slice of byte. And it implements unmarshaled JSON. And all it does is it just takes the JSON and stores it. That's it. It's really powerful because it essentially lets you do whatever you want. And I was going to say, before we go on, I'm close to getting full. So I'm going to stop the recording, save it, and then start over. So give me 2 minutes.
Sounds good.
Sure. Let's
GC
do it.
pause.
Take a break. Yeah. Stop the world.
What up, Gophers? Jared Santo here, your humble producer. I'd like to tell you about something new we are beta testing around GoTime. It's a membership program which we think could be really valuable for the whole community. We call it Changelog++, and it's the best way to directly support GoTime and all of the podcasts, videos, and other stuff we create here at Changelog. We have big plans and ambitions for this, but we are experimenting for now to make sure there's interest. So when you sign up today, you make the ads disappear. You get GoTime and all the shows you love, just no ads. I guess that means this part you're listening to right now, it'll be gone. We also have some extended episodes planned, bonus content, merch store discounts, and a lot of ideas. But since it's such early days, we are offering memberships at a 40% discount for early adopters. That deal's going on for the month of August, so head to changelog.com/++ to join today, lock in that discount, get closer to the metal, and make the ads disappear. Once again, that's changelog.com/++. We'd love to have you supporting us as a member.
So that's an interesting bug that I have with this program. So it seems to just keep using more and more memory as long as I record, and then I have to close it completely after saving the file, and then just start a new.
Yeah, it is just as though it's putting that audio into the RAM, isn't it?
I guess so, but I don't have time to fix that right now, obviously.
Is the amount of RAM it uses the same as the file when you save it, same size?
I stored the WAV. It was like 160 megs, but it used all of my 15 gigabytes of RAM, so I don't know what it's doing.
Yeah.
Well, so I'm ready again. Apologies.
Yeah, so one question that we're picking up from the channel, this one coming from our very own John Calhoun. You mentioned the Go 1.0 compatibility promise, which I think we all Go developers who have anything in production really, really value. Vis-a-vis the JSON package of the Senate library, are there things that you wish you could put in there right now, but that you're sort of prevented from doing that because of that compatibility promise, and perhaps maybe could find their way into a subsequent version of Go that is allowed to break that backwards compatibility?
Yeah, that is a good question. I think there's two kinds of things that I would fix. One of them are sort of high-level API changes. So what we talked about earlier about the readers and writers, making it seem like it's streaming, but it's not actually streaming, it's buffering. But changing those would break practically every program using JSON. So it's not something that I would ever change in V1. It's just, out of the question. The other kind is subtle bugs and historical problems that have kind of become the de facto behavior that everybody has ended up, some people have ended up depending upon. And one example was there's a type called JSON.number. And JSON.number, it essentially lets you easily support big numbers. And it's just a string type. So when you use it to decode a number, such as, like a 50-digit number, it doesn't matter if that wouldn't fit in an int 32 or an int 64, because it's going to keep the string exactly as is. So that would be like the simplest way to implement big numbers, right? And the way JSON number is implemented, if the input JSON is actually a string containing the digits, it's going to accept that, even though it's not a JSON number. That is not documented behavior. The documented behavior, it says, this decodes a number. It doesn't say anything about strings. So I tried to fix that, or I think it was somebody else, and then I reviewed, I can't remember. And then, as you would expect, a bunch of people said, this broke my code. And I showed, look, with 3 lines of code, you can fix it. It's really simple, and I'm giving them to you, and here's a playground link. But they said, no. Like, this is breaking production. This is breaking the guarantee, so...
Oh, yeah, that does fall into that gray area, doesn't it? Because you shouldn't use it like that, but because it worked, then what do you do? It is a tough one.
And it is difficult because you have to gauge, am I breaking too many users? Like, what is too many users, right? I don't know how people use the JSON package. I could maybe look at the open source out there and see what the code looks like with static analysis, but that would only scratch the surface. I would say, the Go code out there that handles the most JSON is not open source, most likely. So it's very, very hard to tell if something could fly or not.
Yeah, so you have a version 2 draft, don't you, of encoding JSON? What's that for? Is this just sort of your perfect design of this is what you would have if you could?
So for the time being, this has just been a document for me to collect my own thoughts. Because I've been co-maintaining JSON for a few years, and I've been collecting these little nuggets of stress, such as, I can't fix this, and if I try to fix that, people are going to get upset, and I can't touch this because it's, it's restricted by the API. So I've collected all of my thoughts, or at least the ones I can remember, and I haven't gotten to the point where I've designed a new API, because to a certain level that feels futile at this point. Because if I design a new JSON API, it's not going to replace the existing API. And as far as I know, there's no current plan to do a version 2 of standard library packages. And I could potentially write something externally, but in a way, I don't want to add to all the complexity that is, 50 packages that do JSON and Go.
I wonder what a sensible approach would be, whether you could just add some new methods to the JSON package.
Yeah, and that is a good point. And there are some bugs. For example, there's one that I would say affects most code bases out there, which is the standard, you have an HTTP endpoint and the body is JSON, so you want to decode it. So what you do is you take the r.body and you do JSON.newDecoder.decode with the body and then into some structure. And if you do that, it's buggy. If you just do that.
I've just got to go. What do you mean it's buggy? Tell me why, please.
So this was found by Joe, one of the maintainers, I want to say about a year ago. And the bug is the decoder is meant to be useful for streams of JSON values. And that is, for example, when you do go test with the JSON flag, it's going to give you a new line separated stream of JSON values, of JSON objects.
Yeah, that's kind of how I was using it in those tools I was talking about.
Yep, exactly.
In a way, it is kind of streaming in a way. Like it takes the reader. For each object, it buffers it, I guess, but it discards that previous object, doesn't it?
Yep.
Yeah, next time, right. So in a sense, it's streaming.
It appears to you as if it's streaming, but internally, that's not what it's doing.
Well, it's still doing it only one object at a time, which you could say is a stream. It's just if it's a great big fat object, then...
Exactly.
You're in trouble. Yeah.
You might, maybe.
Yeah, so I would say it just assumes that your values are going to be small.
Right.
So it doesn't imagine that you would ever have a JSON object weighing to 100 megabytes. And if you do that, it just goes like, whoops, I'm just going to buffer that, essentially.
You couldn't do that on your machine today, for example. You don't have the RAM.
If you want me to leave, you can just say that.
Please don't. You'll have to in about 8 minutes anyway.
Yeah, I'm currently at 30%. I've still got, like 7 or 8 minutes.
I wonder if it's based on how much you say as well. Surely when you talk, it must use more RAM.
Okay, let me yell into the microphone and then just watch the RAM go up.
I don't know how it structures it. Maybe I know what it's doing. It's storing it in JSON, isn't it?
Yeah.
Maybe, yeah. Maybe every wave is a JSON object.
Yeah, exactly.
Being streamed somewhere.
It's not perfect JSON for every type of data, is it? Sometimes binary data is better.
Which actually leads us to a good segue here, because yes, JSON is awesome. It's human readable, but most of the time, we have machines talking to each other. So are there cases where, for efficiency, right, of transport and storage, perhaps, it just makes more sense to just pick a binary format instead of the text-based JSON passing back and forth, especially if it's a stream of data, or if you're ingesting a ton of information, unless you're debugging really as a developer, maybe perhaps locally. I mean, there's no way you're going to be wading through vast amounts of JSON trying to read that and take advantage of the human readability aspect of it, right? So when should you give yourself a pass, right? And sort of not necessarily use JSON for the sake of using JSON because everybody else is using JSON, right? Like, what is a good sort of a set of criteria for making the decision against using JSON?
That's a good question. Before I answer that, I just want to briefly mention what the bug was in the previous point.
Yeah, we didn't catch that. Sorry, that's my fault for being stupid. Don't worry, it's just more work for the editors. Clap. Okay. You just clap and it fixes it.
Has this ever happened to you? Presenting the Clapper. Clap on the music. It's easy.
Clap on, clap off. The Clapper.
So Daniel, tell us, what's the bug with r.body and reading it through the decoder?
So the bug is that you're only decoding one object. But what if the body contained multiple values in multiple, separated by new lines or something? You're not going to notice. You're just going to close the body straight after. So if the client, even if you don't support that, if the client was trying to send you 3 objects separated by new lines, you're going to use the first one and ignore the other 2, which is most likely not what you want to do. You would either want to error or use all the data.
Yeah, that's quite interesting. If you reach the end of the stream, what happens when you try and decode using the decoder?
Well, I imagine it's going to wrap EOF and give you that error or something like that.
EOF. Yeah. Huh. So you could support it by having a loop and just keep looping and keep decoding. But yeah, but again, that's kind of, I don't know. That's quite strange, I think. When you think about an array in JSON, an array can be, is often many objects, inside an array. That could be the payload, and that would actually still work, wouldn't it? Wouldn't hit that bug. It's just for if you're using new line separated JSON objects.
Yeah, and in that case, you can fix the code pretty easily. You can just add a check at the end that says, if the decoder has more tokens to be decoded, then give some error. You can do that. But the thing is that obviously people have to remember to do that. And to begin with, nobody knew to do that. So it's just, I would say it's a complicated API design because it's very easy to misuse.
Yeah, but to be honest, mate, I don't know of any API where you send multiple lines of JSON like that. I could be wrong, but I don't think I've seen that.
Yeah, if an API was like that, you would probably implement it properly. And I agree, this is probably not a problem in real life, but it's still an edge case that exists and kind of very few people have thought about and is technically a bug.
Well, this is what I love about people that maintain these packages for us. It's really hard and you have to kind of care about everything. But that's nice because it means the rest of us don't have to.
And going to Johnny's question, he was asking about when do you choose between JSON or something that's plain text, some format that's plain text, versus something that's binary. And I think there are multiple schools of thought there. But I think the consensus between most programmers is that if it's something that a human is going to deal with, such as a human is going to debug it, or a human is going to look at it, or a human is going to use it or write it, you most likely want it to be plain text if you can afford it, something like JSON or YAML and so on. But if it's something that has to be efficient, maybe because you have tons of it, or maybe because it's only machines talking to each other, then it might be of interest to you to consider a binary format that's more efficient, that uses less space, and so on.
Yeah, and I think that argument also applies to the whole debate around gRPC versus JSON APIs. It's kind of the same thing. There might be good reasons why you need this really low-level binary. You want it to be the most efficient it possibly can be. But yeah, you hurt developer friendliness for sure. It's nice when you use or even when you're building it, but even using it, if you want to explore what's happening, you can sometimes poke around in the browser inside the little network tab and see the HTTP requests and have a look at the JSON bodies. And I find that to be very useful, particularly if I'm developing. So yeah, which of course I think you'd need extra tooling in order to do that if you were going to use some kind of gRPC thing, I think.
I definitely agree. I would say by default choose plain text and only carefully consider binary. Or even better, support both. Many people that build gRPC services, they add something on top like a REST gateway, and then the client can choose which one to use. Maybe they use gRPC for a machine, but maybe a human that's debugging is going to use REST with JSON.
Yeah, absolutely. I think that's a sound approach, but I would agree, start with the JSON one because in the beginning, that's the most easy to work with, and maybe it's all you're ever going to need.
Are you saying it's a Yagni situation?
Yagni.
What is Yagni?
Oh, you haven't been indoctrinated into the Ruby ecosystem. Yagni is something that was popularized by a very popular framework author in the Ruby ecosystem. Yagni stands for "You ain't gonna need it." So
I'm copying that.
Yeah, it's good, isn't it?
Yes, indeed. I still pull that out every once in a while.
But I do think there's one point that we might have missed here, which is defining your data model. And I think that's probably the place where JSON falls short the most and where it bites people the most. And that's where things like JSON schema come in. But I wouldn't say they're very good solutions. They mostly tried to port the XML solutions from 20 years ago to JSON. I don't think they're a very good approach. I think a proper schema language like protobuf and gRPC are better. So you have to choose sort of the trade-off between, do I use something simple like JSON and then just get going? Or do I choose a schema language that's going to let me define my types properly and so on?
Yeah, and that's probably use case driven as well, isn't it? It's in some situations, if you are working with generic data and you don't know the shape of that data, and that does happen sometimes. I've worked on projects for sure where it's a kind of platform and you don't know what the data is ahead of time. then that does kind of lead you one way or the other. The nice thing about JSON, though, is that you can always add fields to it, can't you? You can always add fields, and previous code will just continue to work, because in a struct in Go, if there's a field missing in the struct but it's present in the JSON, by default it just gets ignored, doesn't it?
Yep, that's a very good point. JSON does allow backwards compatibility pretty easily if you are okay with maintaining the previous fields and so on. And I think most formats are like that. For example, protobuf, if you just add things at the end with new IDs, that's also fine. But it is less intuitive. It is a little bit of extra complexity to think about that. I agree.
But it keeps my old stuff working. So I don't know. It's a trade-off I'm willing to make.
And are there other kinds of efficiencies to be had in the current implementation then? Would it be possible to make changes and, say, reduce allocations in the process of decoding JSON?
Yep. And that is kind of where most of my work has gone. Because I didn't, like I said before, I didn't want to just write a new package and just add to the fire that is making new Go developers choose between 20 packages. So I did do some changes to the internals, such as don't do work twice, or cache some stuff, or remove a bounce check here and there and stuff like that. And I think it was between Go 110 and Go 113 that the decoder, if you mostly use structs, so no maps, it got about 30 to 50% faster, which was pretty nice. But you have to understand that the base point was pretty low. So initially...
You don't have to say that. Just focus on the improvement.
Yeah, exactly.
30% faster.
But I will also say that the packages that claim to be 10 times faster than encoding JSON, they probably ran their benchmarks a long time ago, and that is probably more like 4 times faster by now.
Interesting. Yeah. Huh.
And I definitely think that there's more work to be done, but all the low-hanging fruit has been picked, mostly by me and some others. But there are some things that can still be done without changing the API or breaking the users. And I think the biggest one, and that ties into what the work that Dave has been doing, is essentially rewriting the tokenizer. So what takes in the bytes and says, oh, this is a string, and then this is an open brace, and then this is a comma, and so on.
Yeah. And so that process then, I mean, does it build the data structures as it goes when it's parsing, or does it describe somehow that structure in some other intermediate data structure, if that makes sense?
So one way to go about it would be indeed to build some sort of tree, such as like when you parse a Go file and you get a syntax tree of the Go code.
Yeah.
It doesn't do that. What it does is it tokenizes a value, for example, a JSON object once. So, it starts going through the reader, through the bytes, and goes token, 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 but it forgets them because there's the first pass. It just wants to check if the JSON is valid. And once it reaches the end, for example, the closing brace for the initial brace, then it goes all the way back to the beginning of the buffer. And then it tokenizes again. But this time, when it encounters, for example, open object, then it actually goes and starts an object in the destination value. And if it sees a string, then it tries to decode that into whatever the current destination is, and so on.
That's interesting. I'm surprised it does that, because you'd think it would just do it once, wouldn't you? Why does it do it like that?
So the reason it does it twice is to prevent partial decodes. So if I give you, for example, an array of 9,000 elements and there's no closing token, that is invalid JSON. So what are you going to do? Are you going to spend all the time to decode all those 9,000 elements into your destination and probably mess with your destination data if you had anything there before? Which for an array doesn't make sense, but imagine a map, for example.
Yeah.
So you don't want to do that, at least not in the JSON package. It values correctness. So it says, no, I'm first going to make sure that the JSON is valid, and only after I'm going to decode.
Wow, very interesting.
And I think you could say it should keep a tree instead of keeping the bytes. That might be a little bit more efficient in terms of not redoing work, but I would say you probably are going to end up costing more in terms of allocating objects and so on.
I mean, I'd just go through it once, don't worry about correctness, and yes, do all the work, and then if at the end it's wrong, then you get the error. But you have to wait for it, maybe. I feel like that's more of an optimistic thing. Do you think that would be a bad design?
I'm not sure. I'm about 50-50. I think both use cases are valid. I think the current API tries to be as simple as possible. It essentially only has one entry point, which is decoder.decode, and unMarshal is just a wrapper for it. Because if you look at unMarshal, it just does the thing for you underneath.
Oh, it's not the other way around. I thought the decoder would use...
You thought decoder used Marshall?
Yeah, or unMarshal. Yeah.
So the nice thing about the decoder is that it keeps stuff to be reused later.
Mm.
If it was the decoder using Marshall, then Marshall doesn't have the decoder object to then reuse all that stuff.
Right. Yeah, I see. Huh. Oh, yeah, that's okay. Very cool. Very cool. And of course, this is all open source. So if we want to really see how this works, we can go and read the code.
Yeah, but I would say probably don't look at that code and that API and assume that it's idiomatic Go, because a lot of this was written, over a decade ago.
Mm-hmm.
And it's been, my dirty fingers have been on it as well as many other people's fingers. So it's kind of like a zombie at this point.
That's actually a very good point you raised, because a lot of times, I think many of us in the Go community who have been around for a while basically tell new folks, hey, just go read the standard library. And that's an excellent example, of how to write Go code, right? But that is not always true. We've learned a lot since then, some do's and don'ts and some best practices, and, as we say, some idiomatic ways of doing things. And yeah, the encoding JSON package is perhaps not the best representation of how far we've come.
Yeah, the other thing is it contains lots of optimizations, and it should. And that can come at a cost of code complexity and kind of ugliness, but you don't mind it because it's such an important place to have that. But yes, a junior developer could go and look and see some things in there and think, well, this is how you do this. And probably you wouldn't want to do it like that. Yeah.
I completely agree.
We definitely should not run out of time to squeeze in some unpopular opinions.
I actually think you should probably leave.
So my unpopular opinion is that encoding JSON is fast enough.
Oh, come on.
Wow. This is the guy responsible for making it faster.
Well, I'm going to say generally, where generally means it most likely applies to you.
Yeah.
But it might not apply to the 1% that's doing something completely esoteric, such as handling 20 gigabytes of JSON. But most people don't do that. And kind of my point goes back to the trade-offs, right? Yes, if you pick another package, you can get maybe a 2x, 3x, maybe even 4x improvement. But is it really worth sticking with JSON at that point? The overlap between the people that are stuck with JSON because they are, and the people that have to deal with a lot of data is very small, because the people that have to deal with a lot of data, they generally pick better formats that are faster to decode.
I think that is a pretty solid argument, actually. Yeah, that's not unpopular with me, that one. I think you've nailed that. Yeah. Yeah.
Well, you would think that the amount of people yelling about encoding JSON being too slow would disagree.
Sure. Well, but that's because we gave them the tools to benchmark things. I don't know what you expect. Of course, you're going to be moaning.
Should take them back.
Well, Daniel, thank you so much for coming on the show and spending some time with us. It's been great. You must come back at some point.
It was a pleasure.
Yeah. Thank you very much. Thanks to everyone for listening, and we'll see you next time.
Hey, have you followed us on Twitter yet? You should. We post live recording notifications, clips and highlights from past episodes, links and repos from around the Go community, and more. Follow along and join the conversation. We are at GoTimeFM. This episode was hosted by Matt Ryer with help from Johnny Borsico. It was produced by Jared Santo, that's me, and the music, as always, was provided by the mysterious Breakmaster Cylinder. We are brought to you by the amazing folks at Fastly, Linode, and Rollbar. That's our show. Come back next week. We're talking infrastructure.
Channel++.
Changelog plus plus.
Changelog plus plus. Changelog plus plus.
Changelog plus plus.
By the way, I found what the bug was.
Oh, you did?
Yeah, so if I look at my recording program, it keeps using more memory.
Mm-hmm.
But if I switch to a different window, it doesn't.
It's like
It
quantum.
stops climbing.
Yeah.
No, so I think it's the UI. So the UI keeps showing the wavelength of my voice.
Oh.
And it's probably like keeping the entire UI in memory. And then if I look away, it stops rendering it. And then it stops using more memory.
So it only does it when you're looking at it. So don't look at it. Don't look
So
at
I'm
it.
looking at it now, and it's climbing
It's like-
to 31, 32. And then I
it's
stop
like-
looking at it, it stops.
The Heisenberg principle.
It's like Schrodinger's.
Yeah, Schrodinger's
Cats.
Schrodinger's cat files.
Oh man.
Yeah, it is. It's like once it's observed, as long as changes its behavior. Oh, that's so weird.
Well,
You'd
hopefully it
never
wasn't
think
too
to
bad.
check that, would you? That's such a classic computer bug. That is
Obviously, when I
exactly
did
what
the-
happens.
Obviously, when I did the 5-second recording, I didn't, it wasn't enough time to notice if the memory was coming.
Mm. So you literally, if you minimize the window or have it on a different screen or something when it's not doing it, does the RAM jump back to where it was?
No, it just stays. So in this second section, it climbed all the way up to 30%. So I just minimized the window, and then it just stayed there.
Right. And you just thought, I just don't want to stress about this. I don't want to look at it. And then what?
It works.
And you found it. That's
If you saw me looking up, this was me checking the memory usage and praying that it wasn't about to crash. But again, I
you
apologize
found it.
for that.
Wow.
Excellent.
Daniel, you must come back and debug more of our tech gremlins, please.
Oh my god. No, please. This was very stressful.